Okey, teknik yang kedua adalah interpolation animation, di mana interpolation animation ni banyak digunakan di bawah production Walt Disney Animation. Kebanyakan animasi yang dihasilkan dia akan menggunakan, dia generate based on keyframe animation. Okey, tapi dia menggunakan teknik interpolation. Okey, di mana metod ataupun kaedah ini terawal digunakan dan ianya popular terutamanya dalam penghasilan Walt Disney Animation lah yang korang selalu tonton masa zaman kanak-kanak lah. Dan key image ni dia akan diletakkan pada setiap keyframe untuk kita starting dia punya time, direction, movement dan juga material dan so on lah. Contohnya kita ada keyframe 1 sehinggalah keyframe 4. Jadi dia duduk dalam interpolation. Okay. Dan ada dua jenis interpolation iaitu linear interpolation dan juga spline interpolation. Nanti saya akan terangkan lah. Okey, objek movement ni pergerakan objek di mana animation biasanya dia akan ada pergerakan permulaan dan juga pergerakan akhir bagi sesuatu objek yang kita animate. Okey, contohnya kita nak lantun bola, kita nak lontar bola. Jadi bola tu akan melantun dan dia akan jatuh ke lantai. Dia ada first position sehingga last position lah. Dia akan jatuh pergi keluar. Macam itulah imaging dia. Jadi dia ada interpolation. Okay. Dan contohnya bola ni dia akan ada kunci keyframe 1 sampailah keyframe yang terakhir. Dan kita juga sebut proses ini sebagai twinning ataupun interpolation. Ni sama je lah maksudnya. Jadi ada dua jenis teknik interpolation iaitu linear interpolation dan juga spline interpolation. Dua jenis ni selalu digunakan lah dan ianya bergantung kepada keperluan. Tapi kebanyakannya kita menggunakan spline interpolation sebab dia lebih realistik berbanding dengan linear interpolation. Di mana linear interpolation ni adalah pergerakan objek dalam garis lurus. Macam ni lah, digerak dalam garis lurus. Manakala spline interpolation ni adalah pergerakan objek yang dia ada curve. Dia ada arcs dia. Jadi dia lebih realistik jika dibandingkan dengan linear interpolation. Jadi contoh linear interpolation.
Okay, straight ahead animation works, but a lot of times it's hard to figure out where you're going. A lot of times it's helpful to start by working out what we call the key poses first. For a bouncing ball, that's going to be where the ball is at its highest point and where it hits the ground. I'll start by drawing frame 1 up high. Now let's draw frame 9 on the ground. Now I can draw the in-betweens using these key poses as a guide. I'll draw frame 5 in the middle. We call this a breakdown. Now I can keep adding more frames, subdividing the space. Sometimes it helps to make a little chart to keep track of all the numbers. Great, now let's shoot our drawings and play them back. In fact, we can cheat and make it bounce back by reusing the same drawings on the way back up. The ball's moving, but it's not very realistic. Sometimes, before you get started, it helps to shoot video reference, so you have some idea what you're doing. Remember, the ball needs to speed up as it falls to the ground. Our frame 5 is halfway through the animation in time, but the ball shouldn't be halfway to the ground at that point. Instead, I'm going to draw a new frame 5 that's biased towards the first pose. Maybe I'll draw it a third of the way down. Animators have developed a visual language using these timing charts to show how to space the drawings in between key poses. So frame 5, remember, is a third of the way between 1 and 9. I'll draw frame 3 a third of the way between 1 and 5, and so on. These charts help us keep track of the in-between drawings, so we end up with the proper timing. When we play this back, the ball accelerates towards the ground. Now let's see how we use the same technique of pose-to-pose animation on the computer. We'll start by positioning the ball up in the air on frame 1, just like before. And then we'll skip ahead to frame 9 and put the ball on the ground. Down below the picture, the computer shows us this graph. It's kind of like the 2D timing chart, and it shows us how the computer is going to calculate the in-between frames. The horizontal axis is time, and the vertical axis is how high up the ball is. Check this out. If we project the intersection of each frame onto the vertical axis, we end up with exactly the same timing chart that the 2D animators use. You can see that by default, the computer connects our poses with a straight line in the graph. This is called linear interpolation. It results in even spacing of the poses. When we play it back, the ball will move at a constant rate. Now you give it a try. See if you can animate a convincing bouncing ball using linear interpolation. And here's a hint, you can add extra keyframes in between to get the spacing that you want.
Okey, itu adalah teknik linear interpolation. Okey, saya nak tunjuk lagi satu iaitu teknik spline interpolation. Ni contoh ni contoh. Okay, jadi spline interpolation for animation ni dia ada curve lah. Maksudnya bila kita nak buat pergerakan tangan tu dia tak ada dalam garis lurus dia ada lengkungan arcs dia. Jadi kita akan angkat jari satu persatu, dia akan ada dia punya arcs dia lah. Okay.